Sure. Okay. So I'm going to talk about understanding workflow progress using Parsl's monitoring component. I'll give you a brief intro about myself. So on the left, we've got a history of my inability to leave working with this group as it's evolved. So I've basically been building infrastructure. This talk is about the work that I've been doing building Parsl infrastructure. This year, that's mostly been working with the Dark Energy Science collaboration, which is looking for dark energy using the Vera Rubin Observatory, which Sierra is going to talk about later on. And I'm going to talk about some of the monitoring stuff that we've developed for that. The FunkX group were very excited for me to put a Santa picture of myself in to start Christmas. So that's what I look like. Okay, so Parsl, when you use it normally, is this gray stuff over on the left. You're running something on maybe your laptop or a submit node, and you're running your workflow with the Parsl library, and it goes off and runs stuff on, runs your app code on resources. If you enable monitoring, what happens is it also fires stuff over to an SQLite monitoring database, which collects data about how your run is proceeding. Then when you've got this monitoring database, you can query it. So we've got a tool called Parsl Visualize, which will give you some graphs. You can just do raw SQL if you want. The main thing that I've noticed people wanting to do is actually do their own queries, plots, analyses in Python rather than use any of our inbuilt tools. And so I'm going to sort of talk about the structure of the data as if you wanted to make your own queries. So why would you want to do this? Parsl in its core exposes futures, and basically all you can ask of a future when you've submitted an app is, are you finished? Yes or no, Boolean, true or false. The monitoring component is trying to help you ask more interesting questions, such as, is my workflow really making progress? Are errors happening? Are retries happening? How efficiently are my resources being used? And could I try and guess when this workflow is going to complete? So none of those questions are answered by this Boolean future.done function. And hopefully the monitoring database would help you with this. So if you want to turn on monitoring, when you configure Parsl, you just add one line monitoring equals whatever here, and you run your workflow as normal. And at the end of it, you end up with a file called monitoring.db, which is a SQLite database. And there's your data. So the rest of this talk, I'm going to talk about what happens inside Parsl when it runs tasks and how that maps into data structures in this database. So I'm going to try and talk about what's going on there so that you have some understanding when you go off and try and write your own queries if you're interested in writing your own queries. So the very first table is very simple. When you initialize Parsl by calling parsl.init, that creates a row in the database in the workflow table. And so we've got the time it starts and the time it finishes. It's a very simple span of time. Don't try and understand this SQL schema. I'm going to show the SQL schemas that go along with graphics. But the interesting thing is really a workflow run has a run ID. There's the time began and completed that I showed. And there's other metadata which you can look at offline that describes what's happening with the workflow, task counts and things like that. So once I've initialized Parsl, I can define an app and I can invoke an app and wait for the result. So there's another table, the task table, which is this lovely green line. And we've got, it starts at the invoke time and it runs and it returns. And that corresponds to me invoking the app and then the result returning. and maybe you submit more than one task. It's Parsl. You might submit 4 tasks at once. You might submit 4 million tasks at once, and they're going to run and complete at different times. And so you'll get 4 rows in the task table here, a 5th row over here that apparently you launched later on. There's the schema. Now we have the run ID and a task ID within the run. We've got the times, and we've got a bunch of other metadata. This is probably the richest table in the database. I'll go over some of these fields in a bit more depth a little bit later on. So now I've told Parsl I want it to run this task. It will eventually try to run this task. And a try has 3 stages. It's launched. So Parsl has decided, okay, I want to try running this. I'm going to pass it to an executor. So it might be the high throughput executor. It might be the flux executor that we heard about earlier, whatever. Parsl just is like, okay, I've handed it over to that executor. When it actually starts running, we get a time running event. And when it's finished, we get the return time. And as soon as the try finishes, that also means the task is going to finish. So these are meant to be at the same time. So each of these turns into a row in the try table. So we've got this three level hierarchy of a run ID, a task ID, and a try ID now to identify a row. And there's time information. There's not a lot of other information in here. Okay. So what's the difference between a task and a try? They sound pretty similar, right? There's a few different things going on here. So I might have invoked an app. So I've got a task, but that app has dependencies. So I don't want Parsl to try running this app until all the dependencies are finished. So we won't get a try. We won't try to run it. We won't get a try record until all of those dependencies are finished. And the distinction between the tables captures that difference. The cardinalities differ as well. So normally you submit a task and it runs. But if you've got retries turned on, then I submit a task, I make an app invocation, and maybe there are failures and Parsl retries. So every time it retries, it's a try. They're the same word almost, okay? Or you might be using checkpointing, in which case you ask Parsl to run a task, you make an invocation, and Parsl says, hold on, I've run this before, I don't need to try. So you'll have a task record, but there won't be any corresponding try records. Okay, so if you've got retries turned on, you might submit a task and it tries, it fails, it tries again, it fails, it tries again, and now it gives up. And at the point that it gives up, the task also fails. So a few bits of metadata that are interesting here. In the try table, your task, when it fails, it will have failed with a Python exception. And that gets stored in the string representation of that gets stored in the database. So here is an example from our test suite. We test dividing by 0, and this is the Python exception that we get. So you can pull those out for each try that failed. We also store how many times a task has failed, and there's a new feature which is in master that went in a few months ago that's not in a release yet, called a retry handler, where you can define the cost of a particular failure. So you can plug in a workflow specific function that says this failure, I definitely want to retry lots. Another failure might be very definitively, this isn't worth retrying. So you can plug in your own cost functions there. So this row in the task table stores that. So here's that graph again. As you can see, there's no tries at all. If Parsl decided that this task had been run already, we don't try anything, and somehow the task just finishes without any tries. But it might still take some time because it still has to wait for all of the dependencies to finish before it can decide whether it can be checkpointed or not. So the interesting field here, which it looks very boring, but it's actually, for me, one of the most interesting fields in the entire database is this hash sum. And that is, how does checkpointing in Parsl decide if two task invocations, two app invocations are the same as far as checkpointing is concerned? And what it does is it takes the app definition and all of the parameters you passed in, hashes them up, and generates this code. So this is sort of like a checkpointing key. The code for that, for doing that for arbitrary Python objects, is quite interesting if you like that sort of thing. So if you're interested in how that code gets created, you can have a look at ID for memo. If not, that's just almost like a global task ID that is preserved between runs. It's another way of looking at this. The fourth table, the final table in this, is the status table. And this, I've shown it differently on the graph because it is a table of events rather than time spans. And this shows events that happen to a task. So at the start, a task is pending. When it's launched and goes to an executor, there's a launched event. When we know that it's running, we get a running event. And when it's executed and finished, we get exec done. I put the schema in here. It's boring, so don't even look at it. So the state sequences that you'll see here, right across the middle is the sort of normal one job path: pending, launch, running, done. If there's memoization, it is pending, and then it's memo done. It means we didn't need to run anything. If we're running, we might fail, definitively fail, or we might fail in a retriable way and just loop round and round and round until we're either done or failed. So those four tables are the core tables that capture what's happening inside Parsl, sort of projected out to a database. So there's, every time you initialize Parsl, you get a run representing this workflow time span. Inside that, you'll get every app invocation will give you a task. Every time Parsl tries to run that task, you'll get a try row in the try table. And as Parsl does stuff with the task, as stuff happens, you'll get events in the status table associated with that. So there's a few other tables. Those four are the core data flow task-oriented tables. There's a few others. I'll talk about two of them. So there is a blocks table. So Parsl, some executors in Parsl need workers. So for example, the high throughput executor, the work queue executor, they need workers running on a resource somewhere. And the core of Parsl doesn't care how those, or the task management bit of Parsl doesn't care how those workers appear. It just wants them to appear somehow. So there's another bit of Parsl, which is the scaling code, which knows how to acquire workers. So it can say, all right, we need some workers now. It can talk to your resource manager, like Slurm, Kubernetes. This is basically the provider mechanism. If there's a provider, then it can talk to it here, and it can say, please start up whatever you call a job. So Slurm jobs are called jobs. In Kubernetes, we use pods, I think, I'm not sure, but whatever your resource manager calls a job or a pod or whatever, this bit of Parsl calls a block. And inside a block, there are some nodes, and nodes, like a cluster node, for example, nodes run workers. And so this bit of Parsl can start up worker nodes so that this bit of Parsl is trying to do a try, can run on the worker. There's the block table. You just get a block status and a timestamp every now and then. The interesting links are that you get a job ID, which say it's Slurm, it's the Slurm job ID. And there's also a block ID, which a try table entry says which block it's running in. So this lets you say, well, this task executed in a funny way. Can I go through and see, was there something funny happening in Slurm at the time that this mysterious task failure happened? And so this table gives you that linkage through these two fields. The other field, the final table I talk about, sorry, is this very messy kind of big wide table. If you turn on resource monitoring, every few seconds, Parsl will look up the various process stats of your tasks, so CPU time, disk usage statistics, and store them in the database. So this just gives you a raw, if you want to debug, is my process suddenly consuming a lot of memory and I don't really understand why? You can turn this on and collect a lot of data. It makes the database quite big, but if it's useful, then it's useful. So future work, at the moment, I'm working on LSST as part of a broader application. So what I'm interested in is integrating data from other layers. So for example, WorkQ we're using and Slurm have different and useful information. And I'm interested in integrating that with the Parsl monitoring data that I've just talked about. If someone wanted me to try and make this run on FunkX, I'm sure I'd be wanting to get access to the internal logs there as well, for example. And on the other side, the applications we have, which are submitting these tasks that are making Parsl invocations, they also have more understanding about what it is they're submitting. Parsl just sees an app invocation. Whoops.
That was me. Sorry, Ben. I was trying to admit someone and I muted you again. Sorry.
Yeah. There's a different UI you can use. Okay, so the application side, applications know why they're making a Parsl call. Parsl doesn't know why you invoked this app. So there's a little bit more information on that side of things as well. And inside a running app, there's some performance information that is application specific. So I'm more interested in saying, why is my whole application doing something, performing in this way, rather than very specifically, why is the Parsl component of this application performing in this way? So I think that's probably, on this project, that's the bulk of my work in the next year. So the summary is, I've talked about some of the execution mechanisms in Parsl, how they're projected into the monitoring database, and hopefully that will help you start asking interesting questions beyond, has my workflow finished? The end.
Thank you, Ben. And very colorful. Certainly some colors in there. Does anyone have any questions? I see Matthew had a question here around.
I don't know how to end my screen sharing.
Don't worry.
I'm trapped. Well, did you end it?
No.
Okay.
You did. Well, no, now we're seeing ourselves. Anyway, Matthew, do you want to ask your question?
Yeah, I was wondering if you can specify wait windows between retry or events.
No, it's something we've thought. It's something we've thought about, and then we ended up not really needing. And it was sort of hard for me to implement, so I didn't implement it. But it's definitely a maybe feature.
Okay.
Yeah. What it starts moving a little bit more into is more like a user pluggable scheduler rather than a user pluggable retry mechanism, which again, that would be an easy plug-in point to implement.
It might be also interesting, Ben, to mention the work that Tom Glansman and co did to build out their own.
Yep. So up here, there are a couple of users at LSST, and they are this little. Oh,
I stopped your screen sharing, by the way.
Yeah, I saw. So at the start, I said we have the visualize tool, or you can make your own Python queries and plots. That little box totally shrinks down a huge amount of work that 2 users specifically have done at LSST on doing histograms of task lengths so they can estimate resource usage, Tom Glansman who I think he's on vacation, so he's not here today, but he gave a talk at the last Parsl Fest, has done loads of interesting analyses on monitoring data for this project, some of which is specific to our applications, some of which is more general.